So nice to be up here finally. Enrique's perfect setup. So I'm Douglas Fallstrom. I run product management at Primary Data. So I learned the number one rule for picking a startup's name is to call it Primary Data because you'll be mentioned 1,000 times by Enrique. So it's very helpful. Joking aside, Enrique couldn't have done a better setup because a lot of what we end up seeing with customers, and I'll go through a couple of customer examples here as we go through some of the slides, is that data, as much as people want to go all flash, they don't have either capacity or money to do all flash everywhere, and they want to tier data. So we'll go through how to manage data by objectives, which is what the company is all about. And a little bit different from policy-based storage management and some of the other technologies. So when you look at storage growth is intense. This is a number from 2014 from EMC. I don't think it's changed much. I don't know if you go back 10 years, it doubled every 4 or 5 years, not every other year. So everybody in this room creates more data every day. This recording is going to be higher resolution today than it was a year ago. Next year it'll probably be 2K or 4K recording. Right? And this translates to our entire society. And the challenge for every storage admin or data admin out there is that they don't get more people to do the job they did yesterday. They get less. Right? And you're requesting to do more with a lot less. You're also forced to pick technologies to go across the border. You're forced to pick what do you want to do, maybe a SAN infrastructure or NAS infrastructure. In most customers I speak with, I spent 13 years with Veritas. I spent 7 years with Sun before then, all doing storage, server and storage stuff. Broad bucket. Everybody has a SAN in enterprise. Everybody has a NAS device. Generally several models, several generations. What we see now, obviously flash coming along, not flash in storage, but flash in servers. So back in the day with direct attached storage, it was a cool thing. You don't have to go over the network. This is being very, very popular. Hyperconverged is one example where this has become a kind of de facto standard. Cloud or object-based storage, we just kind of reference that to cloud when we talk about it because it's more S3-based or Swift-based storage devices. They're able to drive cost down even more. So I love the Enrique talk on hot versus cold data. We see exactly the same thing. We see customers want to put the hot data on flash or memory technologies if they have these extreme applications that require super low latencies, which is not that many these days because it's what people don't realize with 3DX point is that you generally have to rewrite the application the way it works. Same thing with an SSD. If your application is not multi-threaded, it's really, really hard to get performance out of that thing from an SSD perspective because SSDs are meant to serve multi-threaded applications, not a single thread, unless you happen to have a very low latency SSD. This drives a silo effect. But everybody in the room has at least 2 or 3 different storage silos where you can't share data across these silos because they're simply different technologies, different ways of accessing the storage. We had a customer that I'll talk about in details because I like some of these customer examples because that kind of gives you an idea on how technology works and some of their challenges, where every day, around 4 to 5, they submit a ton of rendering jobs in this case. And it just happens to be that have like 20, 30 filers. It just happens to be that every day all the artists hit 1 filer or 2 filers. They don't hit universal everyone because they're generally working on a single project and the way they carve out storage to try to locate that in a single filer or a couple of filers. It's very, very common to end up with the silos. You can't use capacity from the others or the performance from the others to offset the challenge. We did a survey, what we call the storage census, where we asked a lot of big enterprises what they do, and we see, from a storage perspective, and we see 51% or more have large number of storage systems to manage. 2/3 have between 3 and 9. That alone is a challenge. Now, the challenge you have with the silo is that every silo increases your cost. It increases the free space you have to maintain on it. It means you can't get the full utilization out of your storage, whether from performance or capacity or bandwidth perspective. Also forces you into these specialties where you certainly pick ASP type of storage for a type of workload. Again, let's say you have a database project. You may want to say, I want to put this database project on an all-flash device, and I want to put my VMware servers maybe on a different type of storage. I want to put my scale-out infrastructure maybe on Ceph or something similar to that. It forces you again to build these silos specialized for different types of data. And in the end, it's going to be a challenge for you to migrate the data out. It's going to be a challenge for you to manage it to the most optimal complexity or least optimal environment. So we're trying to, when we created Primary Data, we went out to try to address this complexity and storage and scale problem. Right? So we're looking at not only primary data, that part is misleading. We're looking at how do we get storage to become a lot smarter. Building a smarter storage array is great. There were some notions from Enrique that some of the storage vendors are looking at to bet more intelligence into the storage area. I think that's fantastic. I don't think it solves the problem, but I think it's fantastic. It solves the problem in that silo, right? And you may address it differently in this silo versus that silo. And in the end, what you'll have is many types of storage arrays solving similar problems in slightly different ways, and you're going to have to pick. And what you pick on day one may not be right on day 50, right? So as projects evolve, your needs change generally for the project. So the challenge is, how do I make sure that I pick the right storage that does what I want it to do without incurring massive migration challenges or costs later on when I try to manage the data to what really needed. And from that perspective, we introduced the concept of data virtualization. Everybody understands virtualization. Data virtualization is our way of saying we can encapsulate your data. You can put it on any storage device out there, no matter where it is, whether it's cloud, object, whether it's a SAN device or NAS, whether it's all flash local. The way we do that obviously is going to depend on the technology, and we'll go through some of that, how that works. We won't get into super granular detail unless you want me to. But the power of this is as soon as you virtualize something, just like the way VMware virtualized the operating system, that's the way Veritas back in the day virtualized a storage device or volume, that allows you to do things with it that you can't do otherwise, things like moving it around. So we can tier data from SAN to NAS or back. Or we can have a file system and export that lives on both, which generally in the past have been totally impossible because they're incompatible technologies. We can sit on a pure device to serve up very high throughput, low latency I/O, and at the same time move data that's cold into, let's say, a lower high latency, high capacity storage tier. But from an application perspective, you have no other things that have actually changed. And that's the part with data virtualization. As soon as you can encapsulate the object, you can move it around, you can do all kinds of cool things with the actual object. But you can also do things with the metadata about the object. You can understand better on who's accessing the data, what access patterns do they have, what needs does the application have on this particular piece of data. And from that, you can build histories of the data. So you can understand, well, maybe the first 3 days every month, it needs high-performance storage, and then it needs nothing for like the next 27 days. And then it's back to high-performance storage again. So once you can build this knowledge about your data, you can actually put the data in a more appropriate storage layer. And that's what we've done. So primary data, I've separated the data into two chunks, a logical data plane and a physical storage plane. And we give you the option of manage them separately. It's a very traditional way of doing virtualization where you have a control plane that sits as a kind of a control path. So if an application wants a piece of data, we just simply tell the application where it is. And all the storage folks in the room saying, how does this really work? It doesn't make a whole lot of sense to me before I understand it. And so I'm an old storage guy, so I had the same challenge when I talked to David about this long time ago the first time. And what we do, we create a global data space that allow you to encapsulate all your storage devices. How we access these devices change depending on what the device is. We have open source code that sits inside Linux that allows you to use NFS version 4 transparently with any our storage. All the open source stuff is something we work with open source community to get in there. On the storage side, when we have things like block level access, we can put what we call the DSX, the data services VM in between that allows us to transport and transform the data from a block to file level, for example. I should make one thing very clear to make sure people understand. We're not a block virtualization layer. Everything we share out today, with the exception of VMware, is files and objects. We don't give you fiber channel targets. We're probably going to do IceGuess at some point. We're definitely doing block in NFS v4. That's a different technology that's coming out. That is not really that widely known yet, which is really cool. But if I take a step back, a global data space that encapsulates all these types of storage, you can run all your apps on top of this data space. And first question I always get like, well, how do they not conflict with each other? How do you know where to put the data? And, we can have a system that's fully automated, which is our perfect world. And I'll show you how that looks. Or you can say, I still want to keep my databases on my SAN, for example. I like to keep my databases inside this VMware environment. So it allows you to have a level of control. The benefit of abstracting the data on one level is so you can move it around. So if your database suddenly requires, let's say your storage device suddenly, for whatever reason, incurs, let's say it's a hybrid array for the sake of discussion, suddenly has high latencies. Our system can trigger on that immediately and move the piece of data to a system that doesn't have high latency, and therefore you can maintain it. So for example, if you have a world of hybrid storage devices, because eventually any hybrid storage device will run out of horsepower and you run on hard drives. It's just inevitable. We can actually load balance across those and ensure that we always get the most optimal one. Or if you have an all-flash device, you can put the low latency workloads automatically on an all-flash device. That allows you to segment and use all the single global data space. It might be a single export, you might have 100 exports, it doesn't matter. This is a physical global data space that you then carve logical entities out. And it allows you to co-locate apps across these, whether they're virtual machines, like a VMware environment or a KVM environment, OpenStack, or if they're more user-based files, or if they're like a rendering farm from a big media and entertainment company. A lot of interest we've had initially, and I'll take you through some of these examples, is media and entertainment has been hugely interested in this, because by separating out the metadata from the data, we generally can give you much more value out of your storage without incurring the metadata cost. That's an interesting side effect. So when you look at our architecture, the control plane sits what we call DataSphere, a pair of dedicated servers, could be virtual machines, could be bare metal. The deployment choice is yours. And then you have storage beneath here. So when a file is opened, depending on the type of file, let's talk NFS, for example, or SMB, just to keep it straightforward. When a file is opened, you obviously go to your mount point, it opens it. The mount point actually comes from a DataSphere environment. We'll tell you where the data is, and after that, your client will go directly into the storage. So one thing that was important when we built our product was to give the customer ability of using the features of the storage they already invested in without taking those away. Right? So we're not building this software-defined storage array that will encapsulate your data center. I have no interest in that. And what we're doing is we build an engine that allows you to place the data on the type of storage that the data needs. So we automatically measure the performance of storage. We automatically measure the performance of the incoming requests of the data needs. And we can automatically place it to where it's appropriate. So for example, you can have an objective that says, I like to have this type of data, let's say Excel files or database files, to sit on storage that needs 1 millisecond latency. And we can tell you whether you can achieve that or not. And let's say you have 3 arrays that do 1 millisecond latency. We put it, and we'll actually load balance across those 3 arrays. Let's say one array suddenly goes to 5 milliseconds. We'll know that immediately, and we'll start load balance across only 2 arrays. Right? And if it goes back, we'll incorporate it again. And by measuring performance not only at the storage level, but also at the client level, that's where the DSX kind of component comes through. That allows us to get a very comprehensive view of the environment, where we can understand if network, let's say routing is an issue, if something that sits somewhere in the fabric between the application and the storage has become an issue versus the storage itself. So the challenge always, if you only measure performance on one end of the spectrum, you never really get a perfect answer, because you're only going to know one side of the picture. You don't know both sides. So we took the approach of measuring both sides. Right? Everybody loves the fully automated storage because it's great. You just kind of add your storage in there, you connect it all in there. It takes like maybe an hour to configure it all, and you're good to go. The challenge is that very few people are comfortable with a fully automated data center, especially when it comes to data placement. Right? So we also have the ability of grouping things together. To, for example, we can say, if I want my data on all flash, you can group them all in what we call volume groups. So now you can build a group of servers that the data lives within. So you can contain things within certain groups. Now that group could be a physical location. So you can say, I want my data in this rack, right? Or I want my data in this fire zone inside a data center. I want my data in this data center or location, right? And you can actually join these groups together. So you can build this environment out where you say, data lives in here. If something happens in there, it actually goes over here and so forth. So that's all automated, built into the system, but it allows someone to come in with an existing environment and use it the way it is today without any changes. And then slowly move to a fully more automated environment. So you know, the last thing I want when I'm building a product is to tell you to change everything, right? Because the barrier to adopting that product is going to be immense, because you know, the data, the storage person, I'm going to generalize, it's almost like a networking guy to some extent. They don't like change always. They like things the way they are. They work. They figure out the processes. They've done this for 10, 15, 20 years. And it's good. I don't want to change it. But at the same time, they have these challenges that are not upon them or coming upon them that they can't easily deal with. For example, data migration. A general data migration project tends to take at least 3 to 6 months. Generally longer if you have large environments. Right? We can do what we think of data migration with a single click. We just simply say, this storage is gone. Move the data out as you see fit without impacting production I/O, and eventually it will be done. Right? It doesn't have to be very difficult to do data migration. Once you virtualize storage, you can do all kinds of cool stuff with it, data migration being one of them. It's not a problem anymore. Now, if you think of data migration movement not being a problem, if suddenly, I'm going to take it to extreme, which my head of sales like to say, instead of just buying storage, why don't you lease storage, for example? Why don't you lease storage on a 1-year cadence, for example, where storage comes and goes relatively dynamically, and it's okay because data migration is not a problem anymore. We can move data at any point, assuming you have the bandwidth available between storage devices, without it impacting production I/O. So it allows you to have a lot more flexible environments. If your storage needs changed, let's say you thought you're going to be okay with 10% flash and 90% hard drives or hybrid devices. Maybe you need to have 30% flash and 70% hybrid. And in order to do that in a traditional environment, it's extremely difficult. Either you build out your flash that may or may not be able to scale, or you buy another vendor because they may have a better choice at that time. And then you have to change the application. Why would you have to change the application when you want to just get more performance or capacity from the storage? So by virtualizing it and abstracting it, where the control plane goes over here, and storage is allowed to access from an application directly once you know where the data is, it allows you to be very dynamic in your environment. As I mentioned earlier, we maintain a lot of information about the metadata actually. So we maintain information about every file you access in our system. Obviously, we're not going to do that indefinitely, but we maintain every information, that's how you access it, how often, and so forth, which means that you can extract this data if you want to store it long term, because we don't have enough capacity in the normal system to do this on a huge scale. You can store it long term, but that also allows you to build a very, very accurate performance history of data. Right? So telecom companies, for example, when you get your cell phone bill, most folks look at their cell phone bill maybe the day you got it, generally within a couple of days. Right? And then it's stale data, but they're required to keep it, depending on the country, for 5 to 10 years. Right? Same thing with text messages. Depending on the country, they have to keep that for a long time. All this information is stored in storage device, obviously. It's stored generally as files. All that could easily be understood and moved dynamically to different tiers of storage. You can even move it into archiving systems. So the way we support Amazon and cloud today, and we initial support for that is literally an archiving in the destination. So we dedupe and compress the data before we send it to the cloud. That allows us to make sure we have another copy of the data in the cloud. So not only do you suddenly have to have one copy of your data, but if you change the durability and availability data, you might have 2 or 3 copies of the data. And the system automatically determines that you need to have that. Right? So we have 2 components in the product today. DataSphere is a metadata engine. For folks that are familiar with NFS, we're using NFS v4.2 behind the scenes or in the client directly if it's available to abstract the data. Right? That allows us to put all the file metadata in one place or in multiple places with DataSphere. We are subscription-based. Everything is HA or highly resilient in other ways because we're also a scale-out architecture, so you don't have to have a dual node. You can have more. We do recognize that most customers are not using NFS version 4.2. In fact, I don't know of a single customer that's doing version 4.2, which is perfectly okay. We use our DSX data portal as a way of getting legacy protocols in there. So version 3, SAMB access or SMB access, SIFT access, version 2 and version 3. We have obviously Swift and object access. Right now we're running a beta program for that. That allows us to encapsulate most protocols in there. Now, in a VMware environment, VMware allows us to abstract all that into a single data store. So in VMware environment, we work slightly different. So in VMware environment, you can build your storage ecosystem up like this. You have a single data store. Then in that data store, we can have vVol policies that dictate where the data is. So in VMware environment, where the integration points looks a little bit different because all this complexity is hidden from the virtual machine unless you access the data through NFS and SIF separately. As a VMware environment, we have a slightly different picture. But it works really, really well because in VMware environment, you also don't have the exposure into the VMK layer as another file system. It's just an NFS data store. The data services, either VM or physical box, depending on the environment, is also the guy that's doing all the data mobility. And you'll have any number of these. They're totally stateless. In the SMB case, they're actually clustered because of some information in SMB needs to be stateful. This is fully automated. You don't actually configure anything. We just detect and automatically configure things for you. But the data mover, you might have 1, you might have 10. It depends on your environment, how much data you're moving per day. It might depend on your networking topology. You may have 1 data mover in this network and 1 data mover over here because you want to limit the traffic where it goes, for example. I also mentioned this earlier, just we're working very closely with open source and ensuring that all the changes we do into NFS, version 4, for example, and general NFS, by the way, because there's numerous bugs in that we fixed over the years, as well as SMB actually gets pushed upstream. It's very, very important to us that as much as we can maintain an open interface with any client that needs access into their data. Right? We spent, I'm going to say, 8 months figuring out how to display the mobility of a large number of files. And we're talking millions of files here for an end user. We went through numerous iterations, so we came to this core diagram thing. This allows you to look at mobility. It's hard to see on this resolution. It allows you to look at mobility and see. So not only does a user kind of give you a dashboard, it's the middle point here. Cool screen. It's the middle point where you can see capacity, performance, and you can get hotspots and quickly click in and see these are files that currently have this performance target and is not being met. Right? And we'll try to automatically fix things for you, but if we can't, we still got to highlight them in red saying, you know what, you wanted 1 millisecond. All your storage right now is doing 2 milliseconds, so we can't possibly meet this. But we're going to tell you what's impact. So you can understand from our system exactly what application is being impacted by this. Right? So if you know the file names and the path to the file name, generally you'll understand what application it is. Right? You can say whether it's a VM, whether it's an Oracle database or SQL or something like that. We also give you the traditional storage view of that everybody wanted. Give me the array or the volume, utilization, and so forth. All this can be exported into Excel or CSV files that allow someone to use it somewhere else. So the common use case we found for our technology so far is, not surprisingly, data lifecycle management, where we're moving files from tier 1 to tier 2, or tier 0 to 1 to 2, or back. You know, our system is not a one-way street, that's so you define it. We have several customers doing scale-out NAS with us. So one thing that you can do with us, you can configure several standalone shares into our system. We give you global namespace on top of that, and then suddenly you have a scale-out NAS. And we'll automatically load balance performance to each one of those, or capacity, depending on what you want, or both. And maybe one is prioritized over the other. So maybe you'll do performance first. If one volume goes full, we'll automatically use another. So the Eno space is kind of gone. You have capacity in your environment, we'll still store your data. It may not be desired to sit on that storage device, but you won't get an application crash. It's a big deal for some of these customers because they have a hard time predicting capacity to an application, and suddenly you don't have to worry about that part. Suddenly you can just, you know what, this array over here that's not even connected, I cannot use that space. So the Eno space problem is gone. And obviously data migration I spoke about briefly. It's a very quick note on vSAN. We also add file services on top of vSAN. It's kind of a given. You take a DSX component, just use that to export into NFS and Samba. So you can use vSAN backend store. We just announced this together with VMware at VMworld for EMEA. Won't spend a ton of time on it, but just so you guys know it's there. The one thing I do want to spend some time on is the customer use cases. That's worth understanding. So media and entertainment, very, very interesting for us because one, we can help address some of their metadata workloads and bottlenecks where typical arrays for media and entertainment will be like, you know, a NetApp or an EMC Isilon, for example. Great for large files, not necessarily great for small random I/O. And so they have other solutions for it, and we're able to come in and help get more value out of the underlying storage array. As we can offload that into DataSphere, and now you can actually run your storage array at better utilization levels, and you have to over-provision a lot less. So these guys have done, these are real numbers from customers. I'm not just showing these as a marketing numbers. These are real numbers where we use the customers' cost for their systems, and it's developed with them. I can't show you the names yet because not all of these are willing to publicly talk about the solutions. It's always a challenge for a small company to get to that point, but I hope to get there in the next quarter or so. Life sciences are very interesting to us because X-rays, generally you would have X-ray images, and they would work on these year-long projects. The challenge they had was that they wanted to make sure that the information was stored on only devices they're allowed to store this, customer-sensitive information. As part of our objective is to make sure you can locate data only in one, for example, storage array or 2 storage arrays, so you don't spread your data somewhere else. Also, what the challenge was, they couldn't move data over to a cheaper storage array. And so what they were, without changing the application path and so forth. So what we were able to do for them was come in and give you the global namespace, give you the tiering from hot data or hot in X-ray as in the application, and the patient sees the data to when they don't need to see it anymore, but they still need to store for a very long time. And so that's one very interesting point. The global travel leader was here on the West Coast, where very, very typical VMware environment where 3 data centers, 190, 200 ESX servers. Traditionally, here's my EMC, NetApp, SAN, NAS device, go put into VMware. They create all these data stores everywhere. They took an application that figured out how much storage they needed, and they deployed it. And they ended up with a ton of wasted space. They were about 5x over provisioned over the years across these data centers. They needed to implement Flash. In fact, in this case, it was Pure. They didn't know where to put it because they didn't know what applications needed Flash. So they would create just another data store with Flash, and they would just kind of charge more for their end user. So we were able to come in and give you their, instead of having multiple data stores, we get them a single one. And we, through objectives and then what you can think of as policies, through vVol policies, we're able to say, they had the VMs that needed all Flash, they were on Flash. The VMs that didn't need all Flash, they got tiered off into a slower medium, NAS in this case. So we're able to really help them in that area, and that reduced the over-provisioning significantly because they removed all their silos. This is only their VMware environment, and we're working with them on the other environments that are not VMware. So this is what we launched, feels like a long time ago. It's only 2 months. We launched our 1.0. The product that we launched at VMware was focused on VMware. We obviously do more than VMware today. Time moves fast in the startup. And I spoke about some of these features. The simplified management, we like the concept you can get a single vVol data store, for example, or an NFS data store if you're not using vVols. Both are equally applicable, and you can do everything I spoke about today, you can do in either one of them. The over-provisioning is real. That's where we see most of the TCO coming from our customers when we go out and speak to a customer. They have generally too many silos, and we can reduce them. Maybe not all of them. It totally depends on their comfort with implementing technology. The performance-based tiering we do is very compelling. So we're able to move data that's hot dynamically to something that is fast, and also move it back when it's not needed. And you can do this on we measure open files. Every 15 seconds, we get data points from all the clients, and we build these maps up. So it's very, very accurate. So you can move data, if you want it, on almost a minute-like basis. We won't necessarily move it unless we need to, right? So one thing that's important with data mobility is you don't move data. You don't want to touch any data if you don't have to. That's like the #1 rule we have. So we don't actually move anything until we have pressure for it, unless you tell me specifically do it now, right? So the other piece we do with data when we move, we ensure that the data is the same from the start to end, right? So data integrity checks, everything is built into the system, so you don't have to worry about data being corrupted on the wire and so forth. Because generally that's the other exception I hear from customers, like, well, if you touch it, how do you know it's the same when it's actually on the destination? And we can ensure that happens as well. So we solve some of those challenges along the way. The team we have is very, very experienced with running startups. So David and Rick obviously comes from Fusion.io. They're co-founders of the company. We have DeVos as part of our chief scientist, as well as Lance running the team as a CEO. It's a team that's been through this before, and it's a blast to work with these guys. So this is our tagline: getting the right data to the right place at the right time. I like it automatic. Not everybody needs to be automatic. You can do it totally manual if you wanted to. That's the key piece. When you implement us, you can get the benefit of global data space, but you don't have to do the full automation piece. You can move there slowly. Something I think is really important from a reality check perspective, where not everything works from day one. So I'm going to pause. I know I'm probably running on time exactly. I want to see if there's any questions. We're good?
Yeah, so you mentioned, I thought it was funny that you said that nobody's running NFS4, right? So yeah, I got the joke. So anyway, so what is your sort of back off plan there? Your contingency plan? You're selling the storage product into enterprises. Everybody that's using NFS is using NFS3. So how do you do that?
Sure. The answer for that one is pretty. So I'm going to go back and show you the slide where I have the actual answer. The DSX component here that sits inside NFS4 open source component can run anywhere in the environment. So what we generally do in those environments is put DSX VM, virtual machine, or bare metal. Generally it's VMs. Most because everybody's virtualized these days. It's just easy to spin up a VM. And you can have any number of them. Right? So if you need to have 10 for performance reasons, you can. They're totally stateless. That allows us to allow SMB and NFS v3 access into the same global data space with the same benefits. You still get the statistics from the DSX VM into the data center and so forth. The only difference is that you're going through what tradition would have thought as a gateway. Now, because we do the gateway from a scale-up perspective, I'm not as worried about that because if your client needs more throughput or performance than out of one DSX VM, that simply will automatically be rebalanced to second one. And so we take care of that piece automatically. If one fails, it automatically failed over and so forth.
So I almost hate to ask this, but that implies then that you support some of the sort of also-ran file systems like ZFS or RiserFS or
not today.
Okay.
No.
All right.
So in the back end, we can support any NFS export anybody has.
Got it.
We prefer to have brand name vendors because we can also at that point offload services like snapshots, replication, and so forth to the underlying device because we know what they do. For the type other, as I like to call them, like say ZFS-based appliances and so forth, we have customers doing that and it works perfectly well, but we don't know what services they offer because generally they don't have standard APIs like a NetApp or an EMC that we can then offload the services. Because if you do snapshots and clones or what have you, we actually offload that into an underlying storage device. So we use the technology already deployed, already known, that's at scale as well. And so we don't have to go and rebuild it again.
Makes sense. Thank you.
Sure.
Okay, one more.
Okay, I may have missed this, but you had a slide indicating some of your customers with by industry. You had the. Can you name specifically any the customers?
No, we don't share customer names just yet. The industries we're going after is media, entertainment, oil and gas, financials. You've got life sciences. You could argue tourism and travel would be one of the verticals. Our product today is designed for a large enterprise environment. It's not designed for an SMB environment. The vSAN attached, we've seen interest from vSAN because we've seen a fair amount of interest from a vSAN perspective. It's more to add file services into vSAN, and that kind of encroaches a little bit into the bottom end of the spectrum, where honestly our pricing model may have to change at some point. But the customer names I'm not sharing just yet. I wish I could.
Good.
Pretty much.
Thank you very much.
Cool. Thank you.